Hello everyone. So let's solve this question based upon the series. It is asking which of the following series converges. So to solve this question, we have to solve each and every option and we will see which one is converging. So we'll be using the different rules. So let's start with the first one. In the first one, it says this is the series 3n over n plus 2, n goes from 1 to infinity. So for this one, we can use the limit test, divergence test over here. So an is equal to general term is this. So let's apply the divergence test. Limit n tends to infinity for the an. So test says if this is not equal to 0, then series diverges. But if it is equal to 0, then we cannot say anything. So therefore, if you apply the concept limit n tends to infinity 3n over n plus 2. Now in this case, it is a polynomial upon polynomial, and the degree of the polynomial is same in the numerator and in the denominator. So when the n goes toward infinity, so answer for this is ratio of leading coefficient. When the degree is same, so ratio of leading coefficient is the answer. So in the numerator, leading coefficient is 3, in the denominator it is 1. So we are getting it as 3, which is not equal to 0. If it is not equal to 0, therefore it diverges. So option A is not the answer. Now let's do the option B, 3n upon n square plus 2. So option B says 3n over n square plus 2. Here if you apply the divergence test, so if you apply the limit n tends to infinity, since the degree of the denominator is more than the numerator, so answer will be 0. And if it is 0, we cannot comment whether it is converging or diverging. Here we can use the limit comparison test. So what the limit comparison test says, an is equal to 3n upon n square plus 2. Let's take another term for bn, for which we should know its nature, right? So I'm taking the bn as just similar to this 3n upon n square. I'm just removing this 2. 3n upon n square means basically 3 upon n. Now I want to check. So basically my series is 3n upon n square. Now I want to check whether this particular series is converging or diverging. So this is in the form of p series test. What does the p series says? Sigma 1 upon n power p, and goes from 1 to infinity. If p is greater than 1, then it is converges, but if p is less than equal to 1, it diverges. So right now the p value, which is the exponent of n, is 1. 1 means diverges. So therefore this one is diverging, this series diverges. Now if this series diverges, according to limit comparison test, we will take limit n tends to infinity an upon bn. Now if this answer, if this is positive and finite, this is positive and finite, then both have same nature. Same nature means the bn if diverging, so this is also diverging. If bn is converging, this is also converging. So that's why we already know bn is diverging. So let's figure out this thing. So limit n tends to infinity. What is an? An is 3n upon n square plus 2 divided by bn. Bn is 3 upon n. So when we divide by 3 upon n, it will get reciprocal. It will become n upon 3. So it is 3, or 3 you can cancel also. The 3 can be cancelled over here. So on simplifying, it will become n square over n square plus 2 limit n tends to infinity. Now again we can see n is going toward infinity, polynomial upon polynomial, and degree same. So ratio of leading coefficient is the answer. Leading coefficient is 1 and 1. So 1 is the answer. So 1 is positive as well as finite. Then both have the same nature. So if bn is diverging, therefore an also diverges. So again, B option is not the correct answer. Now let's see the C option, 3n upon n square plus 2n. 3n upon n square plus 2n. Here also we can use the limit comparison test. So an we already know. Let bn I am taking as 3n upon same thing, 3n upon n square, which will be 3 upon n, and again it diverges by p series just like in the previous one. So therefore I will say limit n tends to infinity an upon bn. So an is this and bn is 3 upon n, so it will become n upon 3. Again the same thing, 3 will get cancelled out. So it is n square over n square plus 2n. Polynomial upon polynomial, degree is same, so ratio of leading coefficient is the answer, which is 1. So 1 is positive and finite. So if this is diverging, so definitely this will also diverge. Therefore an also diverges. So again this is not the answer. So now let's see the option D. Option D says 3n square upon n cube plus 2n. 3n square upon n cube plus 2n. Again we can say the bn we can take as 3n square upon n cube. Let's remove this 2n. We can take anything, right? We should know its nature, right? So n square will get cancelled out, so it is 3 upon n. Same logic, it is diverging by p series. So again we will say limit n tends to infinity an upon bn. So an divided by bn is 3 upon n, so it will become n upon 3. Again 3 will get cancelled out, it will become n cube over n cube plus 2n. Now again the degree is same, so ratio of leading coefficient is the answer. So answer is positive as well as finite, so both will have same nature. So since the bn diverges, therefore an also diverges. So definitely D is not the correct answer. So now definitely E is going to be the correct answer. So let's see how. 3n square upon n power 4 plus 2n. 3n square upon n power 4 plus 2n. Now again I am using the limit comparison test. So I am taking 3n square upon n power 4. Here if you cancel out, this is only n square. Now here the p value is 2, which is greater than 1. So according to p series test, it converges, right? In the p series test, what happens is, look at this. If p is greater than 1, it is converging. If p is less than equal to 1, it diverges. So this is converging. So now we will be using the limit comparison test. Limit n tends to infinity n power 4 plus 2n divided by bn. Bn is 3 upon n square, the simplified version. So it will become n square upon 3. 3 again get cancelled, and it will become n power 4 upon n power 4 plus 2n. And it says limit n tends to infinity. So limit n tends to infinity over here. Again, the degree is same of the numerator and denominator, so ratio of leading coefficient is the answer. So it is positive and finite, so both will have same nature. So this time the bn is converging, therefore an also converges. So option E is going to be the correct answer for this. Which one of them is converging? So we can say option E is converging. So I hope you have understood the divergence test and the limit comparison test we have used in solving this. So if you like this video, please subscribe to the channel, and thank you for watching this.